2014 C3. So at this stage, you've looked at vertical and horizontal traces, the oblique plane. You've looked at the hedral angle, but this question has a new part in it where you have to calculate the angle. Sorry, you've been given the angle and you have to find a height at the end. Okay, so this question is a little bit harder than what we've been used to. So you've been given the concept design for a proposed US Marshals Museum in America is shown in the graphic below. The planning of the building was inspired by a pentagonal star shape on the Marshals badge. C3 shows the plan elevation of the three intersecting triangular surfaces A, B and C, which form part of the structure. The outline plan is based on a regular pentagon. Draw the regular pentagon and complete the given plan and elevation of surfaces A and B. So all we can draw at the minute, we can draw all of the plan and we can do the elevation of A and B. We can't do C because we do not have this point. When it comes to doing any of these questions, the first thing you must look at is the scale. It's 1:500. So 6 meters, that's 6,000 millimeters. It needs to be divided by 500, which is 12. So 6 meters becomes 12 millimeters. 12 meters becomes 24 millimeters. 24 becomes 48. 30 becomes 60. Essentially, you're doubling the measurements. We are starting off in the plan in the middle of the page and we're going to draw a pentagon. You should really know how to draw a pentagon at this stage, so it shouldn't be any trouble for you. Keeping it, as you can see, low to the page. Start off with your base. The base of this needs to be 60 wide and we're going to do the pentagon with the angle of 72 degrees. I'm just drawing vertical lines in for this, just so when it comes to using my protractor, that'll make it a little bit easier for me. The angle is 72, but you should already know that. Okay, so 72 degrees on each side. And draw in the angle. Grab your compass, take the edge length of 60 on your compass and strike it off in each of those lines. Okay, now that you have the 5 points of the pentagon, okay, you actually don't really need to draw the pentagon. Now I know it has shown it in light and you can do it in light if you like, and we will, but it's the surfaces A, B and C that are actually important. We'll get to that in a second. And as you've been shown from the diagram, find the surfaces A, B and C. Label them A, B and C. I'm also going to label the vertices of these points. I'm going to label them 1, 2, 3, 4 and 5. Just because I will be using these points later on and it's important that I have them associated with labels. Draw your elevation, so bringing up all 5 points or more if there is any more. Draw your XY line as if given in the question. And all you're doing now is measuring up the 6, 24 and 48. People make the mistake of doing 12, then 24, then 48. It's 12, then another 24, then another 48. So it's quite high. So move your set square up. You're then doing 24. and then you're doing 48. Transfer the measurements across the page. And find the surfaces A and B. When you have that done, relabel your points. I have 3, 1, 2, and 4. I don't know where 5 is. I haven't been given a height, and that is the whole problem of this question. Okay, so reflecting back on the question, we have part A of the question done. So it says, draw the regular pentagon and complete the given plan and elevation of the surfaces A and B. We've that done. We're going to label that in a second. We're asked to now determine the dihedral angle between surfaces A and B. So at this stage, I hope you've got the hang of how to get dihedral angle, but there is kind of 4 steps that you need to use in order to solve it. So dihedral angle, you need to find the line of intersection and get the true length of this line. That's your first auxiliary. We're going to do that now. You can do this in colour if you like. It's not really necessary, but some people kind of like to use these as revision notes after, which makes it helpful if it is in colour. So surfaces A and B, the line in between them is the line of intersection. So we need to get the true length of that line. I'm just going to highlight it in colour first. Okay, and I'll refer to that colour again later. Now, it doesn't matter if you go up or down your page in order to get this auxiliary, but I have space here, so I'm going to do it to the left-hand side. I'm just going to give myself enough space for you to see that. And in that auxiliary, I need to bring out 2 points, one from surface A and one from surface B. Considering I'll already have used 1 and 2, 3 and 4 are the next obvious choices. So the XY line, keep it close, has to be parallel. Bring out 1 and 3 and 2 and 4. Once you have them all brought out, you always work from your last XY line back. So at the minute, I'm going to be taking heights from the elevation and transferring them into that auxiliary. I'm just going to get it all in view so you can see it. One and 2 are the most important for the moment, so just take the height of 1 and transfer it onto your line 1. The height of 2 onto your line 2. 4 is also the same height, so I might as well measure that at the one time. And finally 3 onto the line 3. Label 2, 1, 4, 3. 1 and 2 was my line of intersection, so that's the one I'm going to be drawing first. So that's the true length of the line of intersection. You now need to look along the true length of that line intersection and bring out the 2 points. So what we've done at the moment is we've got the true length of the line of intersection. We're now going to look along the true length line to see it as a point and also bring out the 2 extra points to measure that angle. So look along it, that means continue that out at the same angle. Bring out 4 and bring out 3 and draw your XY line close. Now, I never labelled my XY lines earlier on, so the first one was X1, Y1. This is my second one, X2, Y2. And you always measure from your last XY line back. So This is my new XY line, this is my last XY line, so I'm going to be measuring back into the distances now. So I'm just going to again show you my last XY line and back. The only one that's going to be tricky to measure is 3 because it's so small. I am going to measure that with my ruler or set square. So for me that is, it's almost 4 mil, is it? Yeah, it's almost 4 mil. Okay, so there's 3. And you need to take the distance to 1, 2 and 4. 1 and 2 are the same distance apart, so that's why it's parallel lines. So that's my distance to 1 and 2. It's the same. So when I look along 1 and 2, I see it as a point. 1 and 2 are exactly there. And finally 4. Take the distance from my XY line, strike it off. Now that we have, sorry, now I know you didn't see that. Now that we have 1, 2, 3 and 4, 1 and 2 is the center of the angle. Join 1 and 2 to 3 and 4. And just noticing from the last couple of questions that you've been doing over last week, a lot of you aren't putting in the construction for the dihedral angle. You need to do these 2 little triangles and the dot in the center. And you also need to measure that angle. So just measuring it with your protractor. It's 150 degrees, okay? Yeah, it's 150 exactly. Okay, and write in the 150 degrees. So that's the dihedral angle done. And again, I said I was going to label this. So part A was obviously doing the elevation. That's part A and plan. Part B was getting the dihedral angle, which we measured to be 150 degrees. I'm just going to now read the rest of the question in order to answer the last couple of parts. So part C is to determine the vertical trace and horizontal trace that contains the plane of the surface B. So with that in mind, I am focusing on surface B. Okay, and with surface B, I'm just going to remind you with this oblique plane 6 question that we did. When you have the plane and it's not touching the ground, you're going to shoot the bullet along the surface to make it force it touch the ground. So sometimes you're fortunate enough to have 2 points on the ground. However, in this question, surface B, there's not 1 point on the ground, let alone 2 points. So we need to force points to touch the ground. If I join 2 to 4, it will never touch the ground because it's parallel to the horizontal plane, so that's not going to work. I could join 4 to 1, and I can join 2 to 1, and I'll get 2 individual lines that will touch the ground. I'm going to repeat that in plan. So in colour, you can do this in colour if you like, I'm going to let 1 and 4 touch the ground. Okay. Likewise in plan, I'm going to continue on 1 and 4. And I'm now going to see where they intersect. So I found the point on the ground in elevation. I'm now going to find that point down in plan. I just didn't want my line too long, so just extending that distance out. I've got 1 point on the horizontal trace. I'm now just going to get a different colour just to get the second point. And repeat. So 2 to 1 this time. As accurate as we can. Join 2 to 1. I've done the same in plan. I've joined 2 to 1 and continued it out. And it's the point that's on the ground that's important. Now that I've got 2 points on the ground, I can get the horizontal trace and come parallel to any point on the same surface and I'll get the vertical trace. So that's really it. So we're almost finished part C. So I'd even label there part C, because like that's how the construction actually worked. So there is 2 points. Now the difficulty with this is, as you can see, sorry, my XY line is not long enough. Nor is my table, as it looks. So I'm just extending the XY line because I can see that it's not long enough for this to work. Okay, and I am just getting everything into viewpoint so people can see what I'm doing. So just get that into focus. Join the 2 points together and extend them till they touch the XY line. So it is still a little bit out of focus, isn't it? Come on, okay. Okay, so there's my HT. Okay, in order to get your VT, you can use points 1, 2, or 4. 2, I think, is one of the higher points. Yeah, so I'm going to use the point 2. I'm going to come parallel to the HT from 2 and find that point in elevation, and that will be a point on my VT, and then I'm finishing that off. Okay, so parallel. See where it touches on the ground, which is there. Grab your T-square now. And bring the height of 2 across to meet it. Where it intersects, okay, that has to be a point on your VT, and you'll just join it back. So that is the point on your VT, as is this one here. So in heavy, draw that line. So that's your VTH. Okay, and that's that part of the question done, that's part C. Again, I'm just going to move it out of focus for a moment. And I'm going to talk about part D of the question. So at this stage, we have drawn the plan elevation, we've got the dihedral angle, we've got the VTH of the plane B. And what we're now going to do is we've been told that the dihedral angle between the surfaces B and C is 160 degrees. We now need to complete the surface C. So my issue is, don't have the height of 0.5, but I do have it in plan. I do have the angle, and by using the dihedral angle, I can work backwards to find its height. There will be a little bit moving of the board so you can see everything, but it's between the surfaces B and C, so this is my line of intersection. I'm going to be going through the whole 4 steps again, getting the true length of the line of intersection, looking along it, along with 2 points, and that will allow me to measure the angle of 160 degrees and take a height to transfer into elevation. So there is a good bit involved in this. So the line 2, 4 is my line of intersection. So first thing you're doing is you're drawing an XY line, and this is my third one, X3, Y3. You were going to bring out 2 and 4, obviously, but you need to bring out a point from B and a point from C, so that has to be 1 and 5. So I think I moved my sheet there a second ago. Bring out 2, bring out 4, bring out 5, and bring out 1. When you work in an auxiliary, you always work from your last XY line back. Because this was a plan, it's coming from the elevation, so we're taking heights again. So we've the height of 1 is 12, that's another 24, that's like 36. And we don't have the height of 5, so this line will have nothing on it. It's when we start to get the 160 degrees that we'll be able to measure everything else from it. Okay, so this is the new learning today, is when you have the angle and you start to work backwards. You would have seen this in the 2013 question. It was Beyonce's diamond ring. It was something similar, that you didn't have the tip of the diamond, and you used your first auxiliary in order to find that. So with this in mind, I'm going to take the height of 1. strike it on my line 1, take the height of 2 and 4 and strike it on the relevant lines. And 5, I don't know anything about it. So I have 1, 2 and 4. So my line of intersection is 2 and 4. So I'm just going to join them together. I'm going to do it in another colour to make it obvious. Okay, and I'm calling it the true length of the line of intersection. Something you should be familiar with. And this should be parallel to the XY line, so I'm just double checking that, and it is. It's perfect. Okay, bring out 1. So I'm looking along the true length line of intersection now. And do my XY line close. This is an X4, Y4. And you always work from your last XY line back. So with that in mind, this is my third auxiliary and my fourth one. I'm working from my last XY line back. The distance to 5 is the only awkward one. So I am just going to take my compass and get started. So everything I have at the minute is I have the distance back to 1. And I can strike that off my XY line for 1. So there is 1. The next thing I can do is I can get the distance to 2 and 4 from my XY line. So my XY line to 2 and 4 is the same. And that's why it appears as a point. That's 2 and 4. And the XY line back to 5 I can also measure. But my issue is, well, I don't know where line 5 is. But I do know it is this distance away. So I'm just going to strike it on 2 and 4 for the moment. And I know somewhere, so I'm drawing a parallel line because I know 5 is on this line somewhere. I just don't know where it is. In order to find it, I've been told that the angle for the dihedral angle between surfaces B and C is 160 degrees. So I can start actually measuring the angle now. I'm going to join 1 to 2 and 4. And now I'm going to grab my protractor. The issue you're going to have is, do I put my protractor to the right or to the left hand side of the line? And my answer to you is, it varies. It really depends on the question. And you can see in this question, they've told you that C is just a little bit above, like that 0.5 there is a little bit above points 2 and 4 for us. So 5 is just a little bit above it. So I'm looking for a point in and around here somewhere. I don't want anything too high. If it's gone up that high, it's too high. So I'm just going to do a little bit of trial and error. If I was to put my protractor here and measure 160 degrees, the line will go out here somewhere and my height will be huge. So I know if I put it to the right hand side of the line in this particular question, it's going to be too tall. If I put my protractor on the left hand side, and I am going to do this now because this is the correct way, and you'll see why now in a second. I measured 160 degrees. I bring the 160 degrees and I extend it as long as I can. Where it intersects, it is my XY line, and this is where the line 5 is. So the 0.5 has to be there. Okay, so that was my XY line. I measured the distance back to 5. I've now seen where the two lines intersect. When I bring that into my previous auxiliary, I'll get a height that I can transfer in my elevation, because all these heights were taken from the elevation. So a couple of small things I need to do here. The little triangle with the little dot in the center and the 160 degrees that I was told about. Now that I have that and I have my 0.5, 2, 4 and 1 were all transferred out at this angle. The 0.5 needs to come back at that angle. So just grab your second set square. 2 to 4 is the angle it came out at. So 5 has to come back at that angle. When it comes back, you'll see where your line 5 is. So this point here has to be, it's on my line 5 and I've brought 5 back to it. That has to be the height of 5. Just want to get that height in colour for you. So for my XY line, which is here, up, That's a height. And that's the height that 5 is. You're going to take that distance on your compass now and transfer that height up here, and it'll get you 0.5 in elevation, which you've been looking for all of this time. So in problem solving, you will have this a good bit where you've been given the angle and have to work backwards in order to find a point, possibly in elevation or in plan, at a later stage. That's the height of 5 now. Again, I'm going to do it in red to show you where all that is coming from. So it was found here first, taken it, we've transferred it, I'm just putting it back in colour for you. But I can draw the surface C now, because 2 and 4 is joined to 5. That's surface C, and that's what we've been looking for all of this time. So here was the question as it was given. You had no height for that. We've just found it using the angle that we've been given in the question, and that completes the 2014 C3 question. It was a tricky one, but it encompasses everything you need to know from this topic. So just on the top, 2014 C3, and this has the dihedral angle. It had the oblique plane. But the most important thing from this question was the dihedral angle working backwards. What I mean by working backwards is you had to do the whole process of the oblique plane, of the dihedral angle, and it found a point for you, and you took that distance and you worked backwards to get that height. Okay, so that is the question fully finished. Okay, so dihedral angle, oblique plane, and dihedral angle working backwards were the main concepts from this question. Try it now, see how we get on. Any questions, let me know.